This is a story about data conversion and naming standards. But really, it's a story about optimization, optimizing systems. And a job I had after I had a job at Pepco, the power company in DC, was this job. I worked for what used to be called Anderson Consulting, but it is now called Accenture. And I got this job because I knew they had offices all over the world, and I wanted to be like an international consultant and live in cool places and have them pay for all my stuff and have fun. I was in my early 20s. I thought, why not? Now's the time. So I got this job and immediately discovered that the first thing that they want you to do in these kinds of consulting jobs back then was to be a programmer, mainframe COBOL. This was what they wanted me to do, mainframe COBOL. And at that time, um, COBOL is an old computer language from like, I think either the 50s or the 60s. And it's used to run large back end systems for like, well, it used to be banking. And this was the state of Maryland, the Motor Vehicle Administration, MVA, and also called the DMV in other places. And so the project was that it was before the year 2000. So it was, I think it was like around 95, 96. And the idea was we had to fix all these dates on these computers. And I didn't want to learn COBOL. And I didn't want to learn COBOL because even at that time, it was a dying language. When I say dying, it's still in use and it's still, in operation. But it was built on old stuff, and I like new stuff. So first of all, I didn't want to invest the time in learning this language that I was only going to use on this one project for the rest of my life and never use it again. And second of all, I have a hard time learning languages, especially computer languages, with all different syntax and all different like grammatical structures, object structures, different structures. Um, with that said, though, I can visualize an entire software architecture, which came later as a result of the story I'm telling you now. So here's what happened. So they didn't know what to do with me on this project. And so they were trying to figure out, because I wasn't going to learn COBOL. Like I was like, no, I'm not learning COBOL. I was like the one person that imagine, there's like 500, shiny, new people, coming out of college or whatever, first job, second job, trying to learn this stuff. And I was the one that said, no, no, I'm not learning this. So they were trying to figure out what to do with me. I guess I was likable enough to say no, but I guess pushing the edge of the envelope on like my utility at this company. And so they had a guy who was fixing computers. His name was Dwayne. And basically he didn't want to fix computers anymore. And I can fix computers because I had a job in college where I worked at like a computer lab, fixing stuff, doing stuff, software stuff, hardware stuff. I like tinkering with machines. I enjoy the insides of machines, taking things apart and putting them back together and upgrading things and trying things. So he had a little cart, with some tools, little tool belt, some little spray cans of like, air, because back then, dust, killed keyboards and everything. Like things broke a lot more often back then than they do today. Hard drives, whatever. So I became the computer repair guy on this project. And that was perfect for me because I had a little cart. I did not have a direct boss. And I pushed my cart around through this project. There was like 100 people on this project, 2 different buildings, big project, lots of developers. I don't remember the peak, 50. So, and then some managers and some other support staff. So maybe 100. I don't know. It was a big project, probably 50. And basically, I got to push this cart around to every corner of this project and ask people what they were doing. What are you doing? What's your like? What are you working on? And I would ask the developers who were like fixing this like mainframe code, like the year 2000 code, what they were doing, like what part of like the MBA system were they working on, and what did it do? What was it called? What did it do? And I asked every person this that I was pushing my cart around. So I had a model in my mind of everything that happened, where they only had a model of whatever it was that they were doing. But I had a spatial model of how, at least the structure of all the pieces of this project from the code level. And then I also asked the managers what they managed, like what were the functions that they managed, and like what were their teams doing, and that could fit together the management layer on top of the operational layer. So structurally, I understood like what people were doing, how I talked to other things, the relative importance of each thing, and the operating structure of the management team that was trying to get this thing done, because we were running out of time. And what was happening is, back then there was the year 2000. For those that don't know, it was the century turned, and there was a time where, to save memory, back in the mainframe COBOL days, if you had a date, and let's say the year was 1999, you would just use 90. You would use 2 digits for the 99. But then when the year 2000 came along, if you had any math that involved that 99, which you always did, always, you'd have negative numbers, like negative dates. So the date between like 2000 and 99 is negative 99 years in the old way. And that's a problem, because this system not only ran the entire state of Maryland's motor vehicle administration, it also ran their payroll system for every like check that got printed, and sent out to like anybody, either who worked in the state of Maryland or like a vendor or anybody. And if this thing broke, it would break like the state, like it would be bad. And so they were investing a ton of money in upgrading the software. At the same time, they were also upgrading the actual hardware, the mainframe itself, from like an old mainframe that was maybe like 15, 20 years old to like a brand shiny new one. And so this was the project. And I was just fixing stuff, just having fun, just messing around. It's been a low profile. And, but I decided that to get to Europe, I was going to fix the hardest problem on this project, the hardest one. And so I, based on my knowledge of what people were doing on this project, there was one room that I had no idea what they were doing. And it was a room that was by itself. It was a little corner. And there were 2 people working in it, sometimes 3, sometimes Jill, Kevin, and Jenny. And they were working on this thing. And I never understood what they were doing. And it turned out one day I asked them. And the reason I didn't know is because they were like, they were by themselves. They were like in this sequestered room, and they weren't like connected to the rest of the project and like in this functional way. And they had and so I went in there and I looked around, and in this room, there were all these shelves all the way around the room. And there was 136 2-inch binders on these shelves with words on them, like FLG001, FLG002. FLG003. Skipped a couple, went to 7, 9, 15, I think. And I asked them, what are in these binders? Like, what is this room? All these 2-inch binders all the way around. And they said those binders are all the programs that run this MBA. So all the programs that other people are like working on out there that have all those dates, those are in these binders. Like the code is in these binders of like what the program is. And they said, we have like the hardest problem on this project. I'm like, what's that? I'm like, okay, here we go. I was like, here we go, good. And they're like, we, as part of the year 2000, upgrade, we're going to convert this data, take the old data, fix the dates, and then we're going to shove it on this new mainframe, the faster one. And they said the problem is if we run these programs back to back to like unload all that data and fix all the dates, it's going to take 3 weeks. And we cannot shut down the state of Maryland for 3 weeks while we're doing this. There's only 2 windows of the year that we have. And if I remember right, it was Thanksgiving weekend, which is 3 days where everything's closed. And I think it was Memorial Day. I think there was 2. And there were only 2 chances left to do that. There was like there was a window for a test, and then there was the window to do it. And then it was like the year 2000. Okay, like that was it. Okay, sorry, like that's the way life worked out at this juncture of time. And there were huge penalties for missing the date, like millions and millions and millions of dollars, because it would break, the system. And so Jenny, Kevin, primarily, were in there, and they were trying to figure out a way to take something that takes 3 weeks to happen in 3 days. That was what their job was, this data conversion, migration, thing. And I asked them how they were doing it, and they had been working on it for like 6 months. They'd been working on a long time trying to figure out like even a way to do what they were trying to do. And it seemed like they couldn't figure it out. And I opened up one of the binders, 2-inch binders, just to see. And I can't write code or read code, but the first page in these binders had this information. It said the name of the program. Let's call it FLG001. Actually, I think it was FLG003S. We'll call it that. FLG003S was the name. And first thing I noticed, there was a naming standard, which meant each of those characters meant something. And this made a lot of sense to me. And the FLG meant that it was the flagging system. And the flagging system was used to flag licenses, flag violations, and create notices that later got mailed out, like with paper, to people. And so that made sense. There was a name, and the name meant something, and also had a number at the end, which was a sequence number. So 1 came before 2, which came before 3, which came before 4. And sometimes it would skip some, and sometimes they had extra letters and stuff for whatever reasons it was. And so I remember the flag, the first one that had this file called the Flag Master, FLG MSTR. This is from like, who knows what, like 1995. So anyway, it's in there. But basically what this thing did is this piece of paper told me the name of the program, what order it was in, what files came into it, what files went out of it. And it also told me how many CPU seconds it cost, how many records it processed, how many records per second. And some metadata about like particular to the mainframe of like where the file was located and like what CPU cluster or whatever it was on, different things that were defined in something called JCL, which I think is job control language, a long time ago. But anyway, yeah, so basically, so it told me enough to know the energy cost of the program, the number of records that it processed, and how fast it processed them. And it told me the dependencies of the order, what came first, what came before it, what fed into it, and what it fed after. And so, so I thought this is enough, because I can visualize the number of records spatially as a spinning gear. So if something is 1,000 records and something is 100 records, there's a 10-to-1 difference between those spatial representations of the numbers. And the speed that this gear is spinning is how many records per second it is processing. And the CPU seconds is the energy cost to make that happen. The total number of records processed after a certain period of time is information. So I map to a line. And I was able to read these 136 binders, the front page. And I stacked that weekend, it was a Friday. By the time I came in on Monday, I had stacked the binders floor to ceiling. in the order that's the optimal order with string connecting them. Somehow there was yarn on this, or the twine on this project. I don't know how. I found some string and some tape, and I was taping, these binders together with string at different heights to show the branching, okay, of what was in series and what was in parallel. So if something was in series, it was stacked. And then if you could branch, if you could run multiple programs at the same time because they didn't have any dependencies and they were in the right sequence in the flow, then I would stack them next to each other and then put a string to show that they were in parallel. So on the Monday, there were all these binders on the floor in different piles with different strings and different pieces of tape. And they came in and they said, "What's this?" I said, "This is the optimal order." And they were like, they were looking at me. And my boss, Jane, my boss came in, and the first thing she said, she's like, "What's this?" I was like, "Oh, it's the optimal order." And of course, she says, "You don't even know how to write COBOL." See, because that's the thing, is like they thought you don't, like what people think about like what it is. The details often don't matter. Okay. And so anyway, so it turned out, and they said, "How long do you think it'll take?" And I said, 12 hours. And that was based on the sequencing of everything and the number of CPU seconds I could consume based on the flow that I had. And it took 12 hours. And later, through some optimizations, we got it down to 8. About like things like where would the file be, and could the file be closer to like where the work was happening, and like there were like physical tapes back then that someone had like grab a tape and then like walk across a room and like put it in a machine. Like this is the this is the era that this was. So it's like the closer, if you understood the layout of the map of the floor, you could even optimize to have things pre-sorted and have these they're called DASD units, but these hard disk drives like ready. And if you had 2 people working, you could have one person sorting them in between steps, and they would just be slotted in when they were ready to go. So these and there were constraints of like how many you could like touch at a time, and how many like slots there were, like all these things. But that's just modeling. So anyway, so that was a long story, but that story really had a big impression on me because one more side story on this project. If you did something good, they gave you these little wooden tokens called tokens of inspiration, and you could trade them for like pizza or like I don't know, whatever, like a movie rental at like Blockbuster movie theater or something, Blockbuster movie rental, or like different things. And at leaving out some stuff, they gave me all of them. I got all the tokens of inspiration, and I could trade it for like a 1-week trip to the partner's beach house, which I did. And I guess the story was important in my life because I realized these models that I visualized, scale models of energy transfer, are not just useful for marbles and ramps. I already knew they were useful for business systems, but I see these models all around me all the time. Energy transfer. This is energy transfer. Same thing as the power plants. The earlier video about supply and demand, and same thing about modeling businesses. Same thing about the distance a kid can run in one day. Time, work, energy, distance, all related in a model.